In 475 BC, a Chinese fish farmer named Fan Li wrote something that would change the way civilizations fed themselves for the next 2,000 years. His treatise, the Yang Yu Jing, described a method so efficient that a single setup could produce more protein per square foot than livestock and more nutrition per acre than any industrial farm. Once built, it would feed your family for decades without buying feed, without permits, and without depending on anyone. Fan Li's methods survived wars, dynasties, and empires because the knowledge was simply too valuable to lose. But in the United States, most people have never heard of backyard pond aquaculture, even though it has fed more human beings throughout history than any other protein system on Earth. That silence is not accidental. Today, we are rebuilding Fan Li's regenerative ecosystem right in your own backyard. By the time you finish this video, you will have the blueprint for a self-replicating protein factory that feeds itself, manages itself, and produces more food than your family can eat. 10 years from now, when your neighbors are stressing over food prices and broken supply chains, you will walk out to your pond and feel a calm that no amount of money can buy. But first, you need to understand what happened to this knowledge and why it was buried. If you are someone who values self-sufficiency and forgotten wisdom, hit that subscribe button right now, because this channel is dedicated to bringing back the knowledge that the modern world tried to erase. Around 3,500 BC, during the Neolithic period along the Yellow River in China, farmers noticed something remarkable after seasonal floods receded. Fish, specifically carp, became trapped in low-lying areas. If they dug those depressions a little deeper and reinforced the edges with clay, the fish stayed, thrived, reproduced, and could be harvested whenever food was needed. This was not farming yet. It was observation, a partnership with what the land already wanted to do. By the Shang dynasty, around 1600 BC, inscriptions on oracle bones referred to garden fishing, what archaeologists now recognize as managed fish ponds integrated into agricultural plots. The wealthy maintained ornamental ponds with golden carp, while peasants maintained working ponds with common carp. Both systems fed people, but only one required permission from the authorities. Then, during the Tang dynasty in the 7th century AD, something unexpected happened that revolutionized aquaculture forever. The emperor's family surname was Li, the same word used for the common carp. Out of respect, or perhaps superstition, the emperor banned the breeding of common carp across the entire empire. Farmers faced a crisis because carp had been their primary protein source for over 1,000 years. But instead of starving, they innovated. They began raising multiple species in the same pond. Mud carp fed on bottom sediments. Silver carp filtered algae in the middle of the water column. Grass carp consumed plants at the surface, and bighead carp ate zooplankton. Each species occupied a different ecological niche with no competition and no waste. Just a stacked, self-regulating ecosystem that was more productive than anything before it. This accidental policy created the world's first true polyculture system. By the time European travelers documented Chinese innovations in the 11th century, village fish ponds had become so common that chroniclers described them as a defining feature of the landscape. Some of these ponds were centuries old, still producing thousands of pounds of protein every year. And nobody was adding feed. The ponds fed themselves. That closed-loop ecosystem, the one Fan Li documented and the Tang dynasty perfected out of necessity, never reached the United States in any meaningful way. When European settlers arrived, they brought cattle, pigs, and chickens, animals that required constant feeding, fencing, and labor. The idea of an edible pond that managed itself seemed too simple, almost primitive. But it was not primitive. It was elegant biological engineering. By the 20th century, backyard ponds in the United States were considered decorative, not functional. Koi ponds for the wealthy and ornamental fountains were common, but nothing that actually fed anyone. The knowledge had been buried. However, in the 1960s, during the earliest concerns about food security, a few researchers at Auburn University in Alabama, led by fisheries scientist H.S. Swingle, began studying those ancient Chinese methods. They built test ponds, some as small as 1,000 square feet, roughly the size of a modest above-ground pool. They stocked them with native species like channel catfish and bluegill sunfish, using techniques GDAIC-wealthy polyculture systems. The results were undeniable. Auburn researchers documented yields of up to 350 pounds of fish from ponds of just 1,000 square feet when managed with basic fertilization. To put that in perspective, a quarter-acre of cattle pasture produces about 200 pounds of beef per year and requires constant feeding, veterinary care, and infrastructure. These tiny ponds, GDAICs, produced nearly double the protein, using a GDAIC GDAIC. The studies were published and cited GDAIC enthusiasts, but then the momentum stopped. No government grants, no extension office GDAIC, and no agricultural college taught it at scale. Because the moment you GDAIC pond in your backyard, you stop buying meat from the industrial system. The industrial meat system in the United States, valued at over $200 billion annually, has zero incentive to promote homegrown protein pre-DAIC. But the knowledge survived, the same way it survived the Cultural Revolution in China and the fall of Rome. Because once you understand the biology, the ecosystem builds itself. Drop a comment below telling me if you had any idea this ancient system existed. I read every single comment, and your thoughts help shape future videos. Here's how the pond actually works, and it is not just about fish. The fish are only one piece of a living, four-part system. First, you have the ducks. In traditional Chinese polyculture, waterfowl were always integrated into the system. Ducks are not just livestock. They are the biological managers of your pond. When ducks swim, they stir up bottom sediments, releasing nutrients into the water column. When they defecate, which they do constantly, they add nitrogen directly into the ecosystem. That nitrogen feeds the algae feeds the zooplankton feeds the small fish, and the small fish feed the larger fish. Ducks also eat insects, aquatic plants, and occasionally small fish, creating a closed loop where every action feeds something else. A small flock of 3 to 5 ducks will also give you eggs. Khaki Campbell ducks, one of the most productive breeds, lay between 280 and 340 eggs per year per duck. That is 840 to 1,700 eggs annually from a tiny flock. Research shows that ducks with access to pond ecosystems can obtain up to 30% of their nutritional needs from insects and aquatic plants, drastically reducing your feed costs. You are stacking functions. The ducks fertilize the water. The pond feeds the ducks. The fish clean excess nutrients, and the plants filter whatever remains, while you simply harvest the surplus. Second, you have the plants. Aquatic vegetation is not decoration. They are the kidneys and lungs of your permaculture pond. Cattails are one of the most efficient biological filters on Earth. Their roots extract excess nitrogen and phosphorus from the water, preventing algae blooms and keeping the ecosystem balanced. A ring of cattails around the shallow edges of your pond will do more for water quality than any expensive mechanical filter. Water lilies provide shade, which reduces water temperature and evaporation during summer. Submerged plants like hornwort and elodea release oxygen during the day, which is critical for fish health. Floating plants like water lettuce and duckweed absorb nutrients so efficiently that wastewater treatment facilities actually use them. Duckweed in particular is remarkable because under optimal conditions, it doubles its biomass in less than 48 hours, and ducks will eat it as fast as it grows, creating a self-renewing food source that costs you nothing. Research in aquaponics has shown that plants can remove up to 90% of nitrogen waste produced by fish. The plants absorb the nitrates, the water stays clean, the fish stay healthy, and you do almost nothing except watch. Third, you have the fish. For most of the United States, bluegill sunfish and channel catfish are the easiest and most legal options. Bluegill grow slower but require zero care. Stock them once, and they reproduce on their own, creating a food source that replenishes itself. They reach harvest size of about 6 to 8 inches in approximately 2 years. Channel catfish grow faster, reaching 1 foot fish that they created aponics that they reacher in the more care. Third meant they reach Old Him Fish Beach as well, and my channel catfish and channel catfish. Channel catfish grow in Prester and the plants. They reach harvest size of about 6 to 8 inches and approximately 2 years. Channel catfish grow completely replenishes, improvedly beautiful, and literally. Third, you have the fish is the richfully sets. The left-handle people get able to care them waste and stuff because they've got produced is and strunk the intrathome. They left-handle people get all waste for me and fortunately fish gather. The objective amorkin that the fish created all waste and stuff the most from the pain hand and passed in within the catting. Third one, you have the fish will break fortune, and they remove the final people create fish and replenishes that reach harvest size of about 6 to 8 inches and faster, reaching 1 to 2 pounds in 18 months in a well-managed pond. Tilapia grow even faster and taste better, reaching 1 pound in just 5 to 6 months under optimal conditions. A small pond stocked with 50 tilapia fingerlings can yield 40 to 50 pounds of fish in a single growing season. However, tilapia is illegal in some states because it can become invasive in warm climates, so check your local regulations before purchasing. Fourth, you have the beneficial bacteria. These invisible workers convert ammonia from fish waste into nitrites and then into the nitrates that plants absorb. This nitrogen cycle is the backbone of the entire ecosystem, and once established, it balances itself. You are not managing a farm. You are stewarding a living system. So how do you actually build this? And more importantly, how much does it cost for a family-scale home protein system? The total setup cost runs between $400 and $600, depending on whether you dig by hand or rent equipment. That breaks down to about $150 to $300 for an EPDM rubber pond liner, $20 to $50 for fish fingerlings, $30 to $60 for ducklings, and $50 to $100 for plants and minor supplies. Compare that to a decade of buying meat at the grocery store, and you will see why this knowledge has been quietly suppressed. First, choose your location. You want a spot that receives at least 6 hours of sunlight per day, but not full sun all day, which would overheat the water. Pick the lowest point on your property where water naturally collects after rain. If you fight the natural contours of your land, you will spend the next decade fighting erosion and drainage. Mark out your pond. For a family setup, aim for about 10 by 15 feet, with a depth of 4 to 5 feet in the center. You can dig this by hand over a weekend, or rent a mini excavator for a few $100s and finish in an afternoon. Create a shallow shelf about 1 foot deep and 2 to 3 feet wide around the edges. This is your marsh zone where plants will take root. The deeper center is where fish will take refuge during extreme heat or cold. If you have heavy clay soil, you can seal the pond the traditional way by lining it with 6 inches of wet clay, compacting it by walking on it, and letting it cure. This method has worked for thousands of years. If your soil is sandy or rocky, use an EPDM liner. They last 20 to 30 years and cost about $1 per square foot. Fill the pond with water. If you use chlorinated municipal water, let it sit for a week so the chlorine evaporates. If you use well water or rainwater, you can stock it immediately. Now, introduce life, but do it in stages. Start with the plants. Plant cattails and irises on the shallow shelves. Add submerged plants like hornwort in the deeper sections, and float some water lettuce or duckweed on the surface. Let this sit for 2 to 4 weeks because the plants need time to root and the beneficial bacteria need time to colonize every surface of the pond. After 1 month, add your ducks. 2 to 5 is ideal for a small pond. They will hit the water immediately, and within days you will see the pond come alive. The water will cloud up slightly as the ducks stir the bottom, but that is normal. It is the ecosystem waking up. After another month, introduce your fish. Stock about 50 fingerlings per 1,000 gallons of water. They will vanish into the depths, and you will not see them for weeks. Do not panic and do not add more fish. They are down there growing in the cool, dark water. For the first 6 months, you do almost nothing. You watch the ducks, check the water clarity, remove excess duckweed if it covers the surface, top off the water level during dry spells, and that is it. No feeding schedules, no chemicals, no tinkering. The pond is finding its balance. By month 6, you will start seeing silver flashes as your fish become visible and grow fast. By the end of the first year, depending on the species, you will have fish approaching harvest size. The ducks will start laying eggs at 5 to 6 months, and 3 ducks will give you between 700 and 900 eggs in their first year. That is about 60 to 75 eggs per month, more than most families can consume. This regenerative system will keep running year after year. In year 2, the fish reproduce on their own if you leave a breeding population, the ducks keep laying, and the plants keep filtering. By year 3, you are no longer managing a project. You are simply harvesting from a living ecosystem that has woven itself into your land. Now, let me address something most pond guides ignore. Winter. If you live in a northern climate where ponds freeze, your fish can survive under the ice as long as you maintain a small opening for gas exchange. A simple pond heater costing about $40 will keep a small hole open all winter. Bluegill and catfish enter a dormant state in cold water and survive under ice for months. Tilapia, however, cannot tolerate water below 50 degrees Fahrenheit and must be harvested before winter or moved indoors. Ducks are cold-hardy and will continue laying through winter if they have shelter from the wind. A simple 3-walled coop with straw bedding is all they need. One more thing most guides will not tell you. In most states, ponds under half an acre require no permits and no government approval. You are simply collecting rainwater and managing it on your own property. However, fish species regulations vary. Tilapia is banned in some states because it could theoretically establish wild populations. Catfish and bluegill are legal nearly everywhere. Check your state Fish and Wildlife website before purchasing fingerlings. But in most cases, you do not need permission from anyone to build this. This is what Fan Li understood 2,500 years ago. And this is what the industrial food system has spent a century trying to make you forget. You do not need their supply chains. You do not need to depend on systems that can fail. You need water, sunlight, a hole in the ground, and the patience to let biology do what it has always done. 10 years from now, your neighbors will be anxious about food prices, shortages, and instability. You will walk out to your edible pond, cast a line, pull out a healthy fish, collect a basket of warm eggs, and feel something most people have forgotten: sovereignty. Not the loud kind that advertises itself, but the quiet kind that does not need to. Because you have built something that cannot be taxed, regulated, or taken away. You have built independence. If this awakened something in you, if you can see yourself standing beside that pond 10 years from now, share this with someone who is ready to stop asking for permission. If this video changed the way you see the potential of your own backyard, smash that like button, subscribe, and turn on notifications so you never miss a video. We are rescuing ancient wisdom that the modern world tried to bury. The knowledge is here, the choice is yours, and the pond is waiting.